Hi everyone, welcome back. In this lecture, we're going to go over two very important rules in differential calculus. Okay, the product and quotient rule. Okay, these are the two rules we're going to look at, and they are exactly what you think you are: multiplication and division. Okay, now let's just go over what we have already learned in this course. We know how to find the derivative of sums of functions. Okay, we know that if we have this sort of function that we have to derive, we know that we can derive each function independently. And when we derive this, we get f dash of x plus g dash of x, right? Like an example is x squared plus x, right? We can derive both the values individually. 2x plus 1. Okay? Simple. We've also covered the chain rule and some other stuff, the power rule and a bunch of other stuff. But when we look at this, right, we see that the sums of two functions, okay, to derive that, you just derive them independently. Is it too much of a stretch to say that the same applies for a product of functions, right? Right. I'm trying to say that if you have f of x times g of x, is it possible that to find the derivative, you just derive them independently and leave them as products? Is that too much of a stretch to get there? Well, it's not that bad of a conclusion, is it? We can either try and prove or disprove this conjecture that we have collected, conjecture that we have made. We can either try and prove or disprove it. Now, to prove it, we will have to show that it works for every single value, okay? To disprove it, we have to show that it doesn't work for at least one value. Why? Because if it doesn't work for every single value, it's just a coincidence. It's not a rule, okay? So let's try and disprove it because it's an easier approach. And without too much thinking, you can come up with this example. Okay? Y is equal to x squared. When you try and differentiate that, we know that the derivative is 2x. Okay? But if we do it using this, okay, we write it like this, then we can use our conjecture that we made up, okay? And we can say the derivative of this is 1, the derivative of this is 1, okay? So you're left with 1. Clearly, that is wrong because it's saying that the derivative of x squared is 1, which we know is wrong, okay? Now you can also think of x cubed, same thing applies. So this doesn't work for quite a few functions, but even if it doesn't work for one, we know that we have disproved this conjecture. This conjecture here is false. What the actual rule is if you have y equals f of x times g of x, two functions being multiplied by each other, you can derive it by first deriving one, leaving the other as is, and then deriving the other and leaving the first one as is. Okay, that is the product rule used for functions that are multiplied to each other. Okay, now another way you would sometimes see it is like this, times v. Okay, the x is just a bit confusing. Okay, so where u and v are functions of x or some other common variable, but let's just say x in this case. So we know that dy on dx is du on dx times v, derive one, leave the other, and then derive the other, leave the one. Okay, and there you go. That is how you would do the product rule. Now, the second rule is the quotient rule, okay, used for division of functions, okay? So if you have a function like this, like if you have something of this form, where two things are being divided, you can use this rule, okay? And you may have already seen how hard it can be when we are dividing two things. So this eases a lot of stuff, okay? So we will try and derive this one, like with a formal proof, and we're going to start with the product rule, okay? So how we're going to do that is, we're going to say that, well, this, first of all, I'm going to say that this is y equals, okay, y equals this. And then we're going to say, I can write this as this, okay? Can I not? Of course I can. Now we can see that this is a function being multiplied by another function, which means we can use the product rule, okay? So we derive the first one, leave the other one, okay? And then we derive this one, okay? And we would leave the f of x as is. Now, how do we derive this? Any ideas? The chain rule, okay? So we have this. We can use our acronym, REIT, okay? We replace the function a with u, okay? And u equals g of x. Let's say this is z, okay? Z equals that. Now z equals 1 on u, because we replaced u with g of x with u. dz on du, so the derivative of z with respect to u is negative 1 on u squared, okay? The derivative of u with respect to x is g dash of x, okay? Simple stuff. And now we do our t and we put them together. So the derivative of z with respect to x is dz on du times du on dx. When we write that down, we get that times g dash of x. And we know u is g of x, so we substitute that back in. And we get g of x whole squared times g dash of x. So just to shorten that, we get g dash of x all over the g of x whole squared. Very long, little, okay? And now we are gonna write that back in to our original proof that we were doing, okay? So we bring that back. We write the derivative of this here, which we found was negative g dash of x over g of x whole squared times f of x. Okay. There we go. And now we can do some multiplying, and we'll see that things start to get a bit more simple and a bit more familiar. Okay, so we get this f dash of x over g of x take f of x g dash of x all over g of x whole squared. Okay, now what I can do is, we have two fractions, and you know, to deal with fractions we need to first get a common denominator, right? And I can do that by multiplying the numerator and denominator here by g of x, right? So I get f dash of x g of x all over g of x whole squared. Okay, again, the g of x here and this two can this g of x cancel, and you're left with the same thing. So we haven't changed much. Okay, that take f of x g dash of x all over g of x whole squared. Okay, one final step. Since we have a common denominator, put that into one fraction. Okay, and this is what you are finally left with. This is the quotient rule in all of its glory. dy on dx. Okay? So whenever you have a quotient like this, you use the quotient rule. Now, you have to learn these rules, like you have to memorize them by heart. And not just memorize them, you have to practice them very heavily. Okay? Why do I say that? Is because these sort of rules are very common in the exam. Okay? So if you have to write out the formula every single time, you're going to take too long. Okay? Instead, I want you to practice it so much that you don't have to write down the formula. You just see your function and you go and start writing your derivative. Okay? Trust me, you will get there, but it will take practice. Not that much. Just a little bit. Keep practicing. And once you start getting to that write down derivative, that's your goal for this section. And we will lead you to it through the example. So have a look at those. Thank you.